Alright, time for Quideo number 5 for AP Stats, our final Quideo of the semester. It's really upsetting because I love doing these all the time. Let's start off here with our basic question, which is about the daily intakes of calcium in milligrams for 38 women between the ages of 18 and 24 years old who participated in a study of women's bone health. Part A of this question, it wants you to display the data in a histogram and then describe the distribution of calcium intakes for these women. So what I did first is organize all those lovely numbers up there, put them in order. I came over here and I used my calculator, turned it on, then I went to lists, edit, and I put in all those numbers over here into list 1 of the calculator. Scroll down, there should be 38, I believe. There we go. Oh, alright, whatever. I know it's 38, so I put them in the calculator. We're going to go with that. Then what you do is you go to second step plot. You go to plot 1, make sure it's on and that you're in a histogram over here. Then you can go to graph right there and you're going to have your histogram. So there we have it. Now we need to describe the distribution. So the spread of the distribution is 2,059 milligrams with a range from 374 to 2,433 milligrams with a center of 845, and then the data is skewed right, as you can tell, and there are potential outliers at 1,933 milligrams and 2,433 milligrams. Now part B wants you to calculate the mean, standard deviation, and standard error. And when you plug on all those fun formulas in, your mean is going to be 926.026 and your standard deviation is going to be 427.23 with a standard error of 69.3. Moving on to part C, I want you to find a 95% confidence interval. So there's your formula right there. It's going to be 926 plus or minus 2.042 times 69.3. Then you get 784.5 to 1,067.5. That's a lot of fun. Love doing these. Then part D wants you to estimate the two largest values and recomputed, which does not make sense. Recomputed. Alright, whatever. Recompute the 95% confidence interval, and then what you notice. So what you do here is you do it without outliers. You take out your outliers from the formula, then refind your mean, standard deviation, and standard error. What you're going to get is 856.2 for your new mean. Your standard deviation is going to be 306.7, and your standard error is going to be 51.1. Now moving on to the advanced question, which deals with probability of winning 2 games, all that kind of fun stuff. Yeah, love probability. Part A of this question asks, are the 2 games independent? Come over here to my answer. No, these games aren't independent, obviously, because the probability of you winning the second game decreases if you win the first game. So the first game's outcome influences the outcome of the second game. On to part 2. Part B of this question is asking the probability that you win both games. So what I did here is I drew out a nice tree diagram to give a nice, picture of what we're going to be dealing with here. You don't really need it unless you want to. And then over here, there's probability formula that you're going to be using. So the probability, I apologize, part B is actually that you lose both games, as you can tell of the ones I circled right here. You're losing both games, not winning both games. So disregard that. Anyway, the probability that you lose both games right here is going to be 0.6 for the first one and 0.7 for the second one. So what you do is you just multiply them together, you get 0.42, so there's going to be a 42% chance that you lose both games. Now, part C is asking the probability that you win both games. So you do the same thing. Multiply the 2 wins, 0.4 and 0.2, and you get 0.08. So there's only an 8% chance of winning both Game 1 and Game 2. Moving on to part D, I want you to do all that fun stuff with the random variable x, be the number of games you win, yada, yada, yada. Construct a model for x. So it's pretty much just saying, the probability that you win 0 games, 1 game, and 2 games. So you do the same kind of stuff right over here, as you can see. So probability that you win 0 games is going to be 42%, and then win-lose is going to be 18%, and then a loss win is going to be 32%, which together your 1 win, 1 loss is going to be 50%, while your win-win is only 8%, as we figured out in part C. Moving on to part E of this question, I want you to find the expected value and standard deviation. Use your expected value formula right there, plug in all your numbers. You get 0.66, come down to your standard deviation formula right there. Plug in all your lovely numbers again in this fantastic formula that I love using all the time, and you're going to get 0.62. Now moving on to the AP question, final question. How exciting. It's dealing with investigators at the U.S. Department of Agriculture wish to compare methods of determining the level of E. coli bacteria contamination in beef. And there's 2 different methods, A and B, of determining the level of contamination were used on each of the 10 randomly selected specimens of a specific type of beef. And then here's all that data right in this lovely chart over here. And then it's asking, is there a significant difference in mean amount of E. coli bacteria detected by the 2 methods of this type of beef? Significance right there. You're going to have to come over here. Bada bang. Phantoms. Gorgeous. Come over here to your phantoms. Start off, I've tried, wanted to find my parameter, make it easier on myself, which is the difference in mean amount of E. coli bacteria detected by the 2 methods for this certain type of beef. Followed by my hypothesis, which is my HO is the U of D is equal to 0, and then my HA is the U of D is not equal to 0. U of D, you're like, what the heck does that mean? Come over here, it actually means that it's the mean difference in amount of E. coli bacteria contaminated beef between methods A and B. Glad we cleared that up. So now I'm going to assume some stuff about this problem, just because I want to, really. Come over here. It says your SRS is stated in this problem. It's approximately normal based on the graph. And you assume independence, of course, because your N is greater than 30. Okay. Now you got to name the test. It's I think we're going to use a match pair t-test on this one just because. Why not? Come over here. There's your formula right underneath. Now we're going to test this. What do we do to test this? I'm glad you asked. I'm going to plug in all my numbers right there. My mean, all that kind of stuff is 0. Standard deviation, my N, all of that good stuff. I'm plugging it into that formula for the match pair t-test, and I'm going to get 1.46. Going to go use my handy dandy tables in the book, which you should know how to use by now, so I don't really feel like showing you. And you're going to get your O for your phantoms, and you're going to get your P value, which is 0.1793, and of course that's greater than 0.05. So you're going to fail to reject the HO that UD equals 0, so that's just not true. Then my statement, got to finish it off with a statement because I love writing sentences in math. We fail to reject the HO that's a difference in mean amount of E. coli bacteria detected by 2 methods for the certain type of beef based on a p-value of 0.1793 above alpha 0.05. Thank you. Have a good night. It's been a pleasure doing these videos. Hope you didn't enjoy them because I didn't. So, yeah, have a great day.